Hi, I hope everyone can hear me up, can see me, audible. Uh, am I being audible? So in the chat section, you can give me a quick response. Yeah, cool. I just hope there is no lag of either of the audio or maybe video. I just hope there is no lag. Yeah. Okay, cool. So, are we expecting more people to join in, or no idea about that? Do you have any idea? Are we expecting more people? Any idea? Okay, so we are expecting more people. Cool. Okay. All right. So will the recording be sent to you? Okay, no idea about that. So we'll have to talk to the management and the people. So literally no idea about it. Okay. Most probably you will. We are recording this up. So most probably you will if you want. So yeah. So before we start on with the session, so you guys are from SRM, right? So from which year are you from? Like second year? Which year are you from, guys? Uh, Little quick with the responses. Final year, second year. Cool. Second year. Okay. First year. Okay. So this is kind of like a mixed people from first year to final year. Okay. Cool. Got it. Got it. Got it. Okay. Okay. So uh, you might have been very familiar with data structures, right? So you might have come across with a lot of things. A lot of people would had been into competitive programming and all of these things. Yeah. Yeah. So, like, may I know that what is the scenario? Like, what are all the data structures before we actually start on talking about, what data structures are and what competitive programming is and how can you get into FANG? Talking about all of these things that we're going to talk in a little while. But as of for now, how many of you are actually comfortable on data structures and you can do little coding on competitive programming? How many of you are like actually seriously, genuinely into data structures and can code accordingly? How many of you who think that yes, we are a little confident on data structures part can code? Code is completely different. If I talk about that, I'm talking about the competitive programming part. If if I give you some problem statement, how many of you can actually sit and write code according to that? Can do CP? Cool. How many of you are feeling comfortable? Ki, yeah, CP is something that we can definitely can do. How many of you? Just want to have a look for how many of the people are actually comfortable with data structures and competitive programming. Just want to have a knowledge. I can code, but not confident about CP. Okay, no problem. What about others? Just want to know the mindset is so that we can take the session to that particular approach. Where if most of the people are comfortable with data structures, so we're going to talk about competitive programming on a very different level. I'm going to tell you few questions, few tips and tricks that you can go around and use if you're maybe trying to get into FANG or maybe trying to get into any of the service based or product based companies. We're going to talk about that after like in a while in the session, but as of for now just want to have a look. Need to get more familiar with data structures and CP. Can code but not really sure about competitive programming. Can do CP, but if it's deep into data structures and complex for me, not a problem. Can code, get stuck in between sometimes. Cool, got it. How many of you are seriously uh, comfortable with linear data structures? So if I talk about linear data structures being like arrays or ArrayList or stacks and queues, how many of you are comfortable with linear data structures? Just linear data structure. I'm not going anywhere in depth, but just linear data structure. How many of you are comfortable with linear data structures? Just array. Okay. I know all the base of the data structures. Okay, cool. Aditi, what about others? How many of you are comfortable with linear part, like arrays and array list and stacks and queues and stuff like that? Linked list, kind of like the thing. Comfortable, cool. How many of you are not comfortable with all of these things? Let's talk about that first. How many of you are completely not comfortable with linear data structures? I'm going to take that session, in that way where I can, not comfortable totally, not at all. Cool. Cool. Okay. For the most part, what I've thought as of for the session, a lot of people generally, if they are getting into competitive programming or preparing for product based or service based company, they generally have a good idea about data structures, but they generally do not have a good idea about non-linear data structures like trees and stuff like this. So as for the session, what I've thought is, what if we go look on some non-linear data structures like maybe trees? How about that? How many of you are not comfortable with trees? I'm being very honest. How many of you are not comfortable with trees and non-linear data structures? We're going to talk about that. How many of you are not comfortable? Because generally I see a lot of people, even developers, if we, what is maps, linear or non-linear? So it's non-linear, not exactly to be very precise. It's non-linear because map is kind of like a mapping from key value pair. So it's non-linear. Okay, yeah. So that was the goal. So we're gonna make this session very interactive. I'm gonna ask you a lot of questions. You're also gonna ask me a lot of questions. We're gonna get stuck, might be on a lot of places, and we're gonna take it together, right? One thing that I want, comfortable with maps but not comfortable with trees and graphs. Cool, not a problem. So for actually getting into graphs and talking about graphs and digistras and stuff like this, you actually need to be very clear and foundational on the things that you talk about trees. So trees is very, very important. And we're going to talk about trees in a very, very detail. I'm going to talk about what trees are, how you can code them up, how you can talk about the competitive questions out of trees. What are the frequently asked questions if you talk about trees? How you can go across that? How you can, talk about all of these things. आप लोगों ने सुना भी होगा इसके बारे में, in order, pre-order, post-order, level order. And there are a lot of questions around the globe. Even if you go around onto the web, you'll see a lot of questions. And we're going to take few of them. We're going to try and understand them. We're going to try and code them up. And that's the goal. That's the whole complete scenario that's going to happen in the session. Before I actually start on explaining stuff to you and talking about data structures, let's first talk about what data structures are and how important these data structures can be, right? You might have come across with a lot of people who would have said competitive programming is the goal. Competitive programming is the key where you can get into. Okay, have you heard about the slang called FANG? FANG ke baare mein pata hai kisi ko? There is something which you call it as FANG. Has anyone heard about that? I'm continuously saying FANG, FANG. So how many of you have no idea about what FANG is? We're gonna take on very scratch level. How many of you have no idea what FANG is? Okay. So for the people who don't know what FANG is, FANG basically shorts for these product-based companies, these tech giants like Facebook. So FANG basically shorts for Facebook, Apple, Amazon, Netflix, and Google. So these are the FANG companies. These are the dream companies that everybody thinks about. Okay, someday or the other, I'm going to go around there and be a software developer and going to code for the world and going to do that. Actually getting into FANG is not a tough job. I'm being very honest. I've cracked one of them. So it's not really tough getting into it. What you actually need to be very precise on is competitive programming. If somebody can throw you with problem statement and you can come out with solution, maybe not so optimal, but try getting into one of the optimal approaches, you're good to go. I'm being very serious. They do not need good CGPAs. They do not need good certifications. They don't even care about which college or from which background are you. If you're good with competitive programming, they're happy to get you on board. And we're going to talk about that, what these people need and what are the kind of like the questions that they throw in front of the interviewee, so that we're going to talk about that. But as of now, we're going to take this session in a very systematic approach where I'm going to talk from the scratch. Then I'm going to pull you up onto very basic questions. Then we're going to talk about few competitive questions which are actually asked in the previous year in these companies like FANG. We're going to talk about that at the end, right? But as of now, as I see, a lot of people are not comfortable with trees. As for data structures, we're going to start from scratch. Okay. before I talk about anything, how many of you have coded trees and all of these things before on any of the programming languages? Programming language is not a barrier. Any of the programming language that you've worked on before, any C, C++, Java, Python, anywhere. No. How many of you have coded trees in any of the programming languages? Have worked before on trees using, okay. You have in Java. Okay. Okay, cool. How many of you have never coded trees? Like no idea about trees. We're gonna go on to the majority. Okay, never. Okay, cool. Not a problem. No idea. Cool. So I see a lot of no's. So we're going to go from very scratch. We're going to talk about what trees are, how these are going to help you. And one thing more, I want to be very precise on them and mark my words what I'm saying. Coding, if you're going into Fang, and not only typically Fang, but any of the product-based companies, they hardly care about which programming language you're into, right? Maybe a situation I feel comfortable with Java, you feel comfortable with C++, completely up to you, right? So if you're comfortable with any of the programming languages, good to go. What you actually need is the problem. We're going to talk about to a problem. I'm going to give you some, few questions that you can try it on your own, depending upon the things that we do in the session, right? So this is the whole goal. This is the whole agenda for the session. Okay. If you are good to go, if you want to ask, definitely you can ask in the chat section. If you're good to go, and if we can start onto the session, and we can talk about few data structures and how you can implement, how you can go across with them, just give me a yes so that we can start on with the session. Quick yes, so that we can move ahead. If you have questions, definitely you can go around onto the chat section, type your doubts if you have, and we can cater that out. All right, cool. What I'm going to do is for the internet purpose, I'm just going to stop the video and I'm going to share you out with the screen. And if you're good to go, if you can see the screens, just give me a yes. How to start from basics. Okay. We're going to talk about that. But as of now, let's keep that aside, right? So I just hope everyone can see the screens now. Yeah, cool. Okay. One thing that you actually need to know before we start on to anything, there is few things that you need to know before you start coding on. But is there something like product-based companies don't hire if we go on to the familiar with Python? No, as I said, programming language is not a barrier, completely not a barrier. So if you're comfortable with Python, go on with Python. If you're comfortable with Java, go on with Java. Completely depends, right? So see, typically if you talk about Python, Python is a huge interpreted language. It's a huge language, right? So if you're trying to do competitive programming on Python, it does not make sense because it's like using a big bomb blast to kill a cockroach, kind of like a stuff, right? You use this for machine learning, artificial intelligence, because this is a really big programming language, right? So if you're comfortable with Python, all right, it's not a problem. But again, choosing a wise language for doing all of these things also makes a lot of sense, right? Now, if I talk about and give you a mere idea that what are the good programming languages that you should be knowing about if you're a competitive programmer, Java and C++, either of the two. If you're comfortable with either of the two, it hardly doesn't matter, but choice of preference. But generally, I see a lot of competitive programming either getting into Java or maybe C++, either of the one. Cool. If you're into OS development, C, Objective C, all of these kind of like programming languages make sense because these are really close to the machine. But this is the whole goal, right? So even if you're comfortable with Python, completely fine. Cool. So what will be the discussion for the session? That's what we're going to talk about. And the topic for the discussion is going to be trees, right? We're going to talk about trees in a very detail, right? We're going to have a look on few things which were available in the linear data structures, but we had to somehow push ourselves to the limit where I say, we talk about some hierarchical kind of like a data structures, which you typically call it as trees, right? What was the need? First of all, the first question that occurs, why are we doing this? Why do we need trees? Why do we need some data structures like trees? Now, a lot of people are comfortable with arrays, right? A lot of people would have come across arrays. कितने लोगों को पता है arrays के बारे में? There are few properties that you should be knowing about arrays. How many of you are comfortable with arrays? Let's start from there. Arrays से start करते हैं. Then we're gonna go on to the trees part. Comfortable? Cool. Now, if you'd been knowing arrays in depth, I'm not talking about JavaScript as of now, because JavaScript arrays are completely different. I'm talking about the general arrays, right? So in general arrays, like in C, C++, you have come across, you see that there are few bunch of data that you have inside an array. Let's suppose I have, let's say 10, 20, 30, 40, 50, let's say, okay? And you know for a fact that if you're doing something on the arrays, what you need is, you need indexes, right? This indexes is something which drives a lot of developers towards it, saying, I can store data, I can access these data in very easy manner, where I can say, if let's suppose let's suppose the name of the array is, let's say A, and I want to access the first element, what I can go around do is just type A0, and the compiler is going to do stuff for you. Yeah, this is the idea, that if you talk about A0, A1, A2, A3, and stuff like this is going to give you the values back, right? Pretty cool, pretty cool. But there is something which you should be very particular about. And why have you come across to the data structures like linked list and the other data structures? Anyone that anyone knows about the drawback that you have in the array? Anyone from the session? If somebody wants to point out the drawbacks, the first major drawback that you see in arrays is what? Let's talk about the drawback first, then we're going to come out to the solution. Size is not a problem. Definitely not a problem. I'm going to show you size is not a problem. Definitely not. Specific. It's good to be specific. Same data. We cannot increase the size. Good. We cannot increase the size. Good. Homogeneous data structures. Cool. Very good answer. Homogeneous data structures. As you know, that arrays either could be of the integer type or string type or any of the type, but you cannot mix types in between. Good answer. Cool. You have to go to the last element. Not a problem. It's completely fine. You have to. He means to say that I have to iterate the array as a for whole if I want to do something. You cannot add the value between. Okay, how many of you know about array lists? Anyone who knows about array lists? Indexes start from 0. It's fine as well. It's nothing hard and fast. Vectors. Yeah. For the people who work on C++, it's something like vectors. Yeah. To overcome arrays, introduced linked lists. No. No. Okay, so for the people who have no idea about this, so I'm just gonna show you something. The editor that I'm using right now, or would be using, that is the IntelliJ. You can go around and use any of the ones that you like. Cool. I'm going to show you a few certain stuff that you can go around. Okay, the thing that we're going to code is going to be in Java, right? So the language that I'm using is Java. For that, what I'm going to do is I'm going to create a new project for you. And let's call this something like, let's say, to go for the Java. The Java version that I'm using is Java 8. So if that's the thing, I'm going to create this template for me. And let's say the name that I want to give is, let's say, webinar. Let's say. Iterating loops is very difficult in arrays, not at all. It's very easy. I'm going to tell you that why have we come across with all of these things. This will make a lot of sense as of now. Yeah. Let's talk about this. Let it open. Let's scan all the files. And then we're going to do something. We'll start from scratch. Okay. So don't worry if somebody is like, kya hone wala hai session mein? It's from starting to beginner, anyone. Even for the people who are working hard for placements, it's going to be very interactive session. It's going to help you a lot if you'd be sitting on 2 interviews. All right, cool. So let's talk about arrays as of now. Okay. Now, let's say the things that the people said is generally size. Let's say, what if I ask my user for the size? Okay. Let's say I come across with the array, and I just call this array as, let's say, any of the array of the elements that I want to give, right? So this is how you declare an array in Java. Okay. Why not Python or C++? Okay, so first of all, I don't have IDs for that as of now. I'm comfortable coding in C++ and Python, but right now the IDs that I can use right now, because as you can see, I only have IntelliJ as of now, because I'm more comfortable with Java. So I'm just gonna go around with Java. It's nothing hard and fast. I'm going to explain you each and everything. Don't worry about that, right? So for the people who are being like, okay, fine, yaar, ye to Java pe kaam kar rahe and stuff like this. Did you do CP in Java in college? No, not exactly. So, as I said, guys, come on. Programming language should not be a barrier. We're going to focus more towards the logical part. So, use VS Code. Why are you guys so centric about कि कौन सी programming language पे काम कर रहे हैं, करना चाहिए, and the IDs? It's fine. I'm using Java. I'm using IntelliJ. How many of you are completely not comfortable in Java? Let's talk about this way. How many of you are not comfortable in Java at all? 2, 3, 4, 5. Okay, a lot of people. This is going to be an issue. First time I'm seeing the code in Java. Ooh, no idea in Java. Okay, this is going to give me a hard time then. Java में comfortable नहीं हूँ. Okay. Okay, how many of you have worked on Java before? How many of you? We are wasting time, guys. We are definitely wasting time. How many of you have worked on Java before? 2 people, 3, 4. Okay. Okay. Little bit. Okay, so I'm going to explain you each and everything. Okay. You'll be knowing about object-oriented programming. Uske baare mein to idea hoga. If I talk about object-oriented programming, you have an idea about object-oriented programming, right? Yeah. Okay. So for the people who have not worked on Java, I'm going to give you an overview on Java. It's exactly the same thing that you do in C and C++, exactly the same way, but inside classes. Nothing hard and fast. Cool. I'm going to give you very basic introduction to Java for the people who have not worked on Java. C# will do, completely will do. C# is also one of the, even you can write code on JavaScript, that is also fine, right? So JavaScript is also acceptable if somebody has worked on JavaScript, right? So JavaScript is also comfortable. These companies have no hard and fast thing, right? Cool. So what I do is, if you talk about Java, this is how you typically declare an array in Java, okay? Same stuff you would have also seen in C and C++, because these square brackets are the stuff which makes the deal go up, right? Jahan pe bhi, make this a point. If you're a competitive programmer, kahin pe bhi, if you see the square brackets, just try and understand that this is an array. Okay, I'm going to tell you a few things. Now, let's say, what if I do something like, let's say I enter a few data inside this, and if I go around and try to make a loop out of it, let's say, this is the same stuff that you have done in C and C++ as well. If I go like this, I maybe less than is arr.length, and let's say I++, okay? And what if I do, let's say, s out arr of 5? So I'm just gonna tell you, for the people who aren't comfortable with this, s out is basically exactly like the c out that you do. Std c out jo aap karte ho, which is the console out. It's exactly the same, but this is how you write in Java: system.out.println and anything that you wanna print. Cool. So it's exactly like c out. So it's the statement like, for the people, it's exactly like c out. And let's say if I wanna c out, let's say arr of 5. Cool. So this is the stuff. The system.out.println looks something like this. This is something to print something. Okay. What if I go around and run this application? Let's see that. Cool. So let it build. It's gonna give you one small little message. What about the package? It's like the header file. No. Packages are basically the bundle of the programs that you write. It's kind of like a folder which contains files. So if you're just gonna go around here, source, you could say com.company. This is the package that I have, and it's gonna contain all the class files, right? So this is the package. Package is basically a folder which gonna contain all your files, all the Java files. Okay. Now, typically you can see that your array is coming something like this. We are calling it a 10, 20, 30, and 40. Cool. Now, in this case, what if I try to do something like, let's say arr of, let's say 5 is, let's say 100. Cool. Now, what if I go and run this up? Let's see this. Let's say if I do arr of 5, let's say I give it as 100. Let's see that. You could see that it's giving you an error saying array index out of bound exception. Everyone can see this array index out of bound. This was one of the points that someone throwed up in the chat section saying, okay, fine, you cannot add and delete something from an in the array if you are trying to do something inside the array. And this is the most crucial part where I'm saying I have a data structure called as array, but I cannot use it fully where if I have something like this, right? So I'm trying to do something, I'm trying to insert something, but I can see that there is no index because once it's made, it's fixed forever. Because how much data does it contain? It contains 4 data. What I'm trying to access is something which is out of reach. Does this make sense? Does this make sense? नहीं समझ आया? कितने लोगों को ये समझ में नहीं आया जो मैंने अभी बताया? Got it? Now, this is the problem where a lot of people might face. Cool. Now, initially, when I declared the array, I typically contained 4 data inside this. And I said, okay, fine. Yeah, this is all. This is the whole array. This is the thing that I'm going to do. But later on in the code, what I did was I tried to access a location which is not a part of the array. I'm trying to access one index of the array which is not described in the array. So it's saying that it's out of bounds. The exception which is coming is saying that you are exceeding the limit of your array, right? What Java has done for you, I'm going to come across with C and C++ as well. What Java has done for you is actually created up a class which you call this as ArrayList. If I say ArrayList, this is the ArrayList, which is a part of your java.util. ArrayList is basically exact same thing that you've done in vectors. How many of you know about vectors? How many of you have used vectors before? No? Not a problem. For the people who have not worked on vectors, it's fine. I'm going to tell you what Java has for trying to do something dynamic in your arrays. There is something of a class which you call this as ArrayList, right? There is something called ArrayList. And what does this ArrayList do for you? Let's try and talk that about. Okay. Let's say I create this ArrayList, and let's suppose the object that I create is, let's say, AL. Okay. And I say new ArrayList. Cool. Now the ArrayList is of the type, let's say, integer. Cool. So integer type ArrayList is something that I want to create. How many of you didn't get what I wrote over here? कितने लोगों के समझ में नहीं आया मैंने जो लिखा है यहाँ पे? This small little statement which I've written over here. How many of you have a problem with that? Let's talk about that first. I'm pretty sure a lot of people who have worked on C++ before, they know how AL is the name of the array name. Yeah, it's the object name, right? So ArrayList is basically a class, and what I'm trying to do is going to create an object out of this class, right? So this is what you call this as object-oriented programming, where you have a class and you can see that this class is imported from any other package, which is provided to by default by Java, right? And what I'm trying to do is going to create an ArrayList out of it. And this ArrayList is going to do all the stuff for you. And we're going to talk about how it's going to help you out. And eventually, because this is how we're going to code. अभी ये सारा code पे करके दिखाऊंगा आप लोगों को. Don't worry about that. Now, what if I do something like al dot? Now, keep that in mind. The ArrayList is the name of the class, which is a part of your java.util. And I'm creating the name as al. You can keep it anything that you want, right? New array or something like that. This is the name of the array that you have given. This is the local variable. And then new is the defined keyword. And this is the constructor, if somebody knows about constructors, right? This is the goal. This is the thing. This is the syntax that how you write in Java, right? What if I do something like al dot? You could see that there are a few bunch of methods, few bunch of functions, which comes pretty handy with when you try to do something on ArrayList. Everyone can see this. So if you can see add, there is something called as M written in front of it. Everyone can see this. Add all, clear, for each, get, index of is empty. Everyone can see this. Yeah. Now this is where Java has helped you as a developer. If you want to try something out, if you want to try something as an alternative for arrays, ArrayList is definitely something that you can go around and try. Now, what if I make use of this? Something called as add, right? Let's add something in the ArrayList. Let's suppose if I add 10 and then I say, let's say add 20. Then let's say I add 30, right? And what if I do a S out for that? S out typically means C out. जो आप लोग C out करते थे, इसको C out करके देखते हैं एक बार, इसको print करके देखते हैं एक बार. So if I go and run this up back again, you'll see something, right? And then we're going to talk about that why I showed you this. You could see this 10, 20, 30. Yeah, it's exactly like push and pop kind of like operations. Exactly the same way, right? And you could see the 10, 20, 30 is now in your array list. Everyone, cool? Got it? Makes sense? So you inserted something 10, 20, 30. And when you try to print that up, it comes over, right? What if I want to add more? How about that? Right? Because this was the part which was making us go into trouble when I was doing something on arrays. Yeah. How about that? How about if I go around and add more stuff? Let's say 40, let's say 50, let's say that's it. And what about if I go around and do the S out again, right? If I go and run this up, you're going to see that your compiler, your Java compiler is happy with that as well. Yeah. Yes or no? Cool. Got it? So this is the advantage of using ArrayList as a data structure. If you're trying to do something using competitive programming and you know for a fact that the size is going to give you an issue, ArrayList is something that you can go and opt for. Cool? ठीक है, इतनी बात समझ आ गई. Of course, you can go around and remove stuff from it. That's also something that you can do, but let's not go too much into ArrayList and stuff. But all the things that I wanted to make you understand is that this is ArrayList. Cool? And in that case, array को जो हम लोगों का what we had was a disadvantage in the arrays. ArrayList has done something which you can eradicate that. ठीक है, itni baat, if you're good with this part, just give me a yes so that we can move further quickly, because there are a lot of things that we're going to talk about. All right. Okay, cool. Now, arrays are typically the stuff that you have used over the years. And the problem here is that, as I showed you programmatically, that if once the size is decided, now if I talk about the size is typically 4, right? The size is 4. Now, let's say I'm going to call this 5 as of now, but what if I talk about indexes? Indexes basically ranges from 0 to 4, right? So 0 to 4 will be the indexes for your arrays. Now, in this case, as I said, if you want to include something more, if let's suppose if I want to do something like a of 5 and let's give it 100, it's going to clash because the size is typically 5 and the indexing are ranging from 0 to 4 and you cannot do anything about it. Cool. Now, as I said, ArrayList was one of the things that you came across with and said, okay, fine, if you are having trouble using array, go around with ArrayList. And there are a few things as well in the ArrayList which nobody mentioned up here, which you call this as consecutive, or maybe, okay, how many of you know that if let's suppose array, if I typically talk about Java, your C++, in that case, when you try to declare an array, you have some memory location assigned to it. Yes, talked about this, stack memory, heap memory. पढ़ा होगा आप लोगों ने इसके बारे में, memory management. Yep. If I talk about the memory management, typically in arrays, you would be knowing that depending upon the size of the data type that it's a contiguous memory. So depending upon the size of the data type, your memories will also be assigned depending upon that. So in Java, your integer takes 4 bytes, right? So in that case, the next address is definitely going to be 104, then 108 and 116 and so on and so forth. Yeah, you knew about this? Ye to pata hoga, most of the people would be knowing about this, right? Yeah. Yes or no? Okay. Now, this again is a problem. This again is a problem. What is the problem? That if you do not have, okay, let's say you working on Pentium maybe, or maybe older machines than that. What if you have a limited space? What about that? If you have limited space, what are you going to do? You cannot create arrays and contain data inside it. Why? Because your array needs what you call this as contiguous memory, right? If you do not have contiguous memory, you cannot allocate data until you do not have a contiguous memory. Yes or no? Yeah, guys, yes or no? Yeah. So this is gonna create problem again. So for that, we came up with the solution called as linked list. A lot of people would be knowing about linked list. Linked list के बारे में तो पता होगा आप लोगों को, where you link your data so that you can come up with the solution saying, okay, fine, I do not want to use this conjugative memory and I want to come across with linked list, which is going to help you do your stuff. Linked list, right? Very, very important data structures. In linked list, what do? You typically create a node in one different memory location, let's say 100, and you keep some data inside this, and you typically contain address for the next node, let's say, which is in, let's say, 4000, right? And you link this by adding 4000 here, and it starts pointing towards this, which actually is again a node which is containing data and few other memory addresses as well, right? So here I can say that even if I don't have consecutive data, I can do something like this. Make sense? इतनी बात समझ आई? पहले arrays था, which was the basic data structures, which came out with two problems. First problem, that you have to do on a very systematic note, that if you mention the size is one of the problems. And then we saw that ArrayList basically solves this problem out, or vectors that you call it as in C and C++. If somebody is interested in C and C++, vectors is a solution out of this. The another problem that I found out, or you guys found out, was that consecutive memory is basically taking a lot of things from you. If you want to code around, this is the problem that's going to definitely want to come across with. So what you thought was that I can come across with linked list as a solution where I can say that, hey, fine, okay, I'm just going to keep data in different locations and I'm going to link them up and call them as linked list. Cool. Now there is one more problem with all of these stuff and all of these things. Actually going to go around and search data in linked list is basically a problem. How? If let's suppose I have few data, let's say 5 data, right? And I try to do something like this, try and understand this part, then I'm going to go on to the trace and try to find out that how you can eradicate this problem statement. So the problem statement is that you have a linked list, which is typically like this, right? And let's say this is 400, this is 300. Let's say I have a node out here, which is like this. Oh, sorry, 500. This is the address for 400. Let's say I create one more node out here. Let's say the data is 5, contains null at the end. And this is the typical data structure. And this is the demonstration that you might have come across with. Yeah? You have seen this linked list like this before? Yes, you have. Now, in this case, if I talk about this linked list, there is a problem with that as well. What is the problem? The problem is the basic CRUD operations. Have you ever heard about CRUD operations? CRUD. Heard about CRUD operations? No. So basically, there are few operations which you call this as CRUD operations, CRUD. CRUD operations basically shorts for create, retrieve, update, and delete. Now, everything in, create, retrieve, update, and delete. Now, in this case, creation is not a problem. Fine. Updation is definitely a problem. Retrieving data is definitely a problem, but deleting data is not a problem. Try and understand this up now. Now, for the people who have been into competitive programming, there have been across a lot of problem statement. If I want to do, let's say, I want to, let's say, organize the data, let's say, in sorted order. And there is a problem statement for that. That if, let's suppose, if I have a linked list and I want to sort that data out, it's going to be a problem. Yes or no? If, let's suppose, I talk about sorting data and managing your linked list according to the sorted order, this is going to be a problem. Yes or no? Just yes or no. If you feel that yes, it's going to be a little pain if you want to do something like that. It's going to be a lot of problem. Yes. What about if I say I need to retrieve some data out? How about if I say that I want to search something like 50 and I want to tell my user that if 50 exists with the in the linked list or not, this is going to be a problem. How? Because you have to go around and iterate this linked list in a from start to end. Yes or no? Yes. So I can typically say that retrieving and updating inside a linked list is a problem. Creating a linked list seems fine. It's fine. Deleting a node from the linked list, maybe from the starting or maybe from the end, it's completely fine, because the only thing that you need to do is maintain the head pointer. Yes. So if, let's suppose, I want to delete this up, I'm just going to make my head pointer go here. I'm just going to delete this head pointer. Sorry. I'm going to delete this head pointer. Yes. And if, let's suppose, I want to delete this node as well. Okay, fine. I'm just going to place my head out here and say, okay, fine. This is where my linked list is going to start from. Yes. So one thing, or I'll typically say two things which are going to make the data structures not so efficient is the retrieval part and the updation part. These are the two things that you need to keep in mind if you're working on linked lists. This is going to give you a lot of trouble. Yeah. If you're good to go till here, just give me a quick yes so that we can start with the solution part, that how you can give the solution something like this. Now, there are few problem statements which are very basic if you talk about linked lists. Few, let's suppose first is, let's say they'll say sort the data in the linked list. Sort the data in linked list. Or find the data, or maybe find the element, or search the element in the linked list, right? Search the element in the linked list. These are few standard questions, right? These are few standard questions that you'll definitely will come across with. Now let's talk about the solution part. What could be the possible solution if I want to do something like this? What could be the possible solution? Well, turns out that you have a possible solution out of it, which you call this as trees. Now, what are trees? Let's talk about what are trees. Trees are basically a way of representation of data. What you were doing in linked list, you were basically trying to create a node, and you're saying that my node will have an address part which is going to contain the address of what's next. What's next, right? In trees, what do? We try to segregate the data in a particular order. Okay, how? Well, if you know trees, or you might have seen trees across, you have something like this. Yeah, have you seen this before? Has anyone seen this kind of like an architecture before? Let's not talk about root and node and stuff like this, but this is the basic thing that we have learned as of now. If someone says trees, this is the one picture that comes and pops up in the mind, that okay, fine, yeah, this is tree. Now, what is making tree so special? This is special because this is not linear anymore. This is hierarchical. Yeah, this is hierarchical. How about now, just try and understand the problem statement. How about if I want to search, maybe let's say C? If I go and try to search C, I can just come here in two iterations and can say, okay, fine, yeah, I found C. Are you getting what I'm trying to say? Is it making sense? That if I say that using trees, I can search my data, I can access my data in lot more easier manner, I definitely can say, okay, fine, yeah, trees is a better approach of rather than using and storing data inside your data or data in the linked list, right? Uh, yeah, sure, definitely. That's why we are here. Of course, I'm going to tell you that. Of course, I'm going to tell you that. Don't worry. We're going to talk about that. We're going to talk about that. Don't worry. And we're going to discuss these problem statements. The typical things that which are asked in trees. Okay, fine. What are the things that you need to know about trees? We're going to talk about that as well. Okay, let's first try and understand the problem statement. Then we're going to go into the coding and do something up. Okay, cool. Does this make sense now? Because hierarchical data structure is going to save a lot of time if you want to do that. As of for now, I'm going to keep one question on hold, is the sorting part. This is for hold. I'm going to tell you that how your trees are going to solve this problem statement, which is the sorting as a problem statement. And we're going to talk about that as well, but not now, little while, when you know a good knowledge about trees. Now, when you talk about trees, there are a lot of kind of like trees. For example, you have something called as forest. Forest is one of the data structures. If somebody would be interested in doing MTech and stuff, they're going to learn about forest because that's the first topic that's going to pop up first. So of course, forest is a type of a tree. This is also a type of a tree. This is the kind of like a tree that you see generally. This is called as forest. Second thing that you definitely would have heard about is binary tree. Have you heard about binary tree? Heard about binary tree ever? Yeah. There is something also which you call this as binary search tree. There's also one other type of tree which you call this as binary search tree. A lot of people would have heard about binary search trees before. Yeah. You call this as red black tree. Then there is something in the AVL. So binary search tree is what you call this as BST. Yeah, BST. This is what you call this as binary search trees. What do you call this as a BST? There are a lot of trees that you definitely will come across. And why do we have these kind of like trees? Because of course, as I said, tree is one of the very important data structures, even more important than linked list, because it solves the drawbacks of your linked list as a data structure and give you a lot more freedom if you want to code around and do a lot of stuff. Is it making sense now? Okay, we're going to talk about that, how typically you're going to do this, but definitely we're not going to talk about forest because this is a little complex part to take on onto the session. The two things which we are going to start from scratch is going to be actually implementing up a binary tree and binary search tree. This is the agenda for the session. That's the thing that we're going to do about it. Cool? Samajh aa gaya? That these are the two things that we're going to talk. One is going to be the binary tree, and the second is going to be the binary search tree. Cool? Okay. Should we move ahead? Let's talk about that. Going to make use of this. Yeah. Just hope. Good job. Yeah. Okay. Cool. Let's do something. Now let's talk about trees. And the trees that we're going to talk about first is going to be the binary tree. Okay, let's start with this binary tree. What does binary means? Binary means what? Binary, as for the word binary, is what? Just talking about English. Two, right? Two is the basic thing that you come across when you say something binary. Not more, exactly two. Having it, no. Not gonna talk about binary is at least one or two, not more than two, but at least either, it could be either one or maybe two, right? Zero or one, either one of the one, right? This is what you call this as binary. Not more than two, not less than one, but something which is ranging from zero and one, right? To be very specific, true. Two is the at most things that you can have. And when I talk about a binary tree is something which contains node. Let's say if I have a node, let's say X as a node, it can have two children out of it. Let's say Y and Z. This is what you call this as binary tree. Again, as I said, it could have one, it can have two, but not something which you call this as more than two, right? On the contrary, if you talk about forest as a data structure, forest is something where I'm saying that, okay, fine, if I have node, I can have multiple children, as many children as I want. This is what you call this as forest. And this is one of the reasons it's called as forest. But if I talk about binary tree typically means what? Either one or two, not more than two, not less than one. Cool. Does this make sense? Is it fine? So what do I need as of now? What I need is a node which is going to act like something and two children out of it. Let's say the left child and the right child. Yeah? Yes or no? This is how I can say that, okay, fine. If I have a binary tree, it should look something like this, that I have a node and that node contains two more data associated to this node, which is going to be called as a left child and the right child. This is called as left child. This is called as right child. Cool? Is it fine till here? Comfortable? Should we move ahead? Yeah. All right. So binary tree means what? Binary trees means node, left child, right child. Cool. But the problem here arises, how can we do this? How can we approach this? How are we going to do that? And let's go around onto the editor and do something out of it. We're going to do something out of it where I say that I'm going to build something which I'm calling this as a binary tree. Okay. So that's the goal. That's the thing that we're going to do. Okay. What have I said? One small little tree which gonna contain a node. And of course, definitely these nodes that I'm talking about as of now, these nodes are typically going to contain some data, right? So if I do something like this, let's say I call this as 10, 20, 30, right? So these nodes are going to contain some data, maybe integer data, maybe string type data, maybe any kind of like data, right? That's what we're going to have a look at. Let's say I go around onto the package and I'm going to create a new file, a Java class file. I'm going to call this as binary tree. The name of the class is binary tree. That's what we're going to build. That's the name of the class that we're going to build. Okay, everyone is here. Everyone is being attentive. Let's talk about how we can build typically a binary tree, shall we? Okay. Now, before I actually start on and try to do something, I like to make your attention towards one thing for the people who have been working into C and C++ as a programming language. You might have done or coded linked list before, right? So you try to do something like you call this a struct node, and then you write something inside it. Remember? For the people who have worked on C and C++. किया ऐसा कुछ काम? We're trying to create a structure. Typically, a structure is what? A structure is basically a collection of different types of data types. Yeah, you have done something like this. Well, if you're working on Java, rather than just calling this as a struct, I'm just gonna call this as a class, and I'm just gonna call this class as node. Right? Difference समझ आया? This is nothing hard and fast, but you used to write struct out there. Here, I'm just gonna call this as a class. So there is a class called as node, which is going to contain few parameters inside it. And what these parameters are, I don't know. But as of now, this is the parameter. Cool? Okay. Now inside this, what do I want? As of now, what I've seen in the PPT, there are few certain things that I need for one node to have. What are these things? First thing is going to be the thing that I need to contain, which is, let's say, the key, which is of the type integer. Again, you can keep this type, maybe string, maybe any of the other type. But right now, I'm just only interested in the integer type of data, right? What are the other things that I need? The other things that I need is what I'm calling this as a left child and a right child of one particular node. This is what I need to mention here. Cool. So what I'm going to do, I'm just going to call this as a pointer. Now, how do you define a pointer in Java? That's what I'm going to talk about. I'm just going to call that I'll have something called as left. I'll have something which I'm calling this as a right. And again, these will again be of the type node. Does this line make sense? That I'm saying that I need two things, which I'm calling this as a left child and as a right child, and be of the type node. Yes? No. Yeah, there are no pointers in Java. That's what I'm saying. I'm going to say that I have something which I'm calling this as a left, something which I'm calling this as a right. Again, they'll be of the type of the class called as node. Saying that if I talk about this, oh, sorry. If I talk about this, if I'm saying node, which I'm calling this as a left child and a right child, this will also contain the same definition that I've written out here, calling that this is going to contain key, left, and a right, saying that it's never ending kind of like a thing, saying that this left will also contain a left, and this left will also contain a right. Then again, this left is also going to contain left, it's also going to contain right, left, right. So it's a never ending process. Does this make sense? It's kind of like, yeah, it's kind of like a user defined data type. Yes. Now, does this make sense? If I say that, okay, fine, I'm going to have a left, I'm going to have a right, but again, this is going to be of the type node. Cool. Does this make sense now? This statement makes sense to people? Everyone? If you're comfortable till here, just give me a yes so that we can move further. Okay. All right. Now, what I'm going to do is I'm going to decide a constructor. Anyone in the session who does not know about constructors? Yeah, it's exactly like what I'm, as I said, aap wahan likhte the struct, a structure used to define a structure out there, but right now I'm not creating any structure. I'm just going to call this as a class, and it's the same thing that you're going to do. It's the same thing, right? I'm just going to call this class. I used to call this as struct before. I'm just going to call this as a class as of now. Again, it's a complex data type. It's going to contain multiple other kind of like data inside this. Right now, it's just going to call this as key, but inside this, I've created something which I'm calling this as left and a right. Does this make sense? If you're good to go till here, just give me a yes so that we can move further quickly. Yeah. All right. How many of you have no idea about constructors? At least I'm going to explain you that way. How many of you have no idea about constructors? It's fine if you don't know about it. It's fine. So everybody has an idea about constructor. How many of you know about constructors? Quick yes. Yeah. So what I'm going to do, I'm just going to create the constructor of this node class. Okay. So I'm just going to say node, the name, exact same name, no return type. And I'm going to say whenever I'm going to create this constructor, I'm going to pass an integer type value, which I'm going to call this as key again. What I'm going to do is initialize this key, which is up top here. I'm just going to assign this to the key that my user has passed as of now. And what I'm going to do, I'm going to say that this dot left equals this dot right equals null. What have I said out here? What does this mean? This means nothing. This is really simple. Let's figure that out. What have I said out here? I said that, hey, listen, compiler, what do I need is typically need a node, which is going to contain an integer type, let's say data, and it's going to contain two things. One is going to be the left, one is going to be the right. These are the two things which are going to contain inside my node, right? Left is again going to be of the type node, which is again going to contain some data, and then it's also going to contain left and right? But now what do I want is that I need my left node and my right node to be kept as null. These are right now null. You have not defined anything inside it. I'm saying that there is no data inside left and right child. The reason I'm just going to call this as null. Make sense? What have I done out here? I said, okay, fine. I'm going to create this too. But right now, I'm just going to keep null inside this because I do not have data to accumulate inside this. So as of now, I'm not going to create node, but I'm just going to call this as null. Does this make sense to everyone? What I've done out here, I said this dot left, this right, assign this as null. Cool. Got it? So what have I done? Created up a node, said, okay, fine, I'm going to have left and right. And what I want to do is I'm just going to keep this left and keep this right as null because I do not have any data inside this. Yeah. Okay. Okay. So this is how I've decided to create a node, right? This is the node which is going to have or which is going to contain everything. What do I need now? What do I need to have this? If you remember, you have worked on linked list before. And if I talk about a linked list, your linked list gonna contain everything like this, right? There are a few linked nodes inside it. And there is one small little pointer that you always maintain, which you call this as head. Yeah. Yeah. This is where you typically know that, okay, fine, yeah, this is where my linked list is gonna start from. Yeah. So you also need one of kind of like a pointer, which is gonna point towards the start of your tree. And a lot of I have heard one or two people saying in the chat section, this is what you call this as root, the root of the tree. Yes, got it? Samajh aaya that what do we have? So what do I need right now is a small little pointer which is going to point towards the start of the tree that I'm going to build as of now. Cool. For that, I'm going to maintain a pointer to point at the start. Do I want? What do you think that I can come across with the type? If I mention the type, let's say int, it's not going to contain any address because typically in Java, your address is contained as a hexadecimal code. Cool. So can I say that, okay, fine, I'm going to have a root. I'm going to have a root, but it's going to be of the type node. Is it fine if I call this node root? Because again, this is a custom data type that I've created. And I'm going to say, okay, fine, my root is gonna be of the type node. Is it fine if I write something like this? Is it fine, guys? Yes or no? Everyone, I'm asking it to everyone. Yeah. Now what I'm going to do is I'm going to create a mean, right? And in order to create a mean, you used to write something like this before, where you call this as a void main. But in Java, this void main has something. Don't get afraid because your main looks really horrible in Java. This is what you call this as public static void main, and the abbreviation is PSVM. This is what you call this as a main. It takes few arguments, which you call this as command line arguments. We're gonna not go inside that, but this is the main thing that you have. And what you're going to do is going to make the object of the tree and going to insert some data inside the tree. How? Let's say I say binary tree, and the name of the object, the name of the object is going to be binary tree, which is starting from small b. Okay, and I'm just gonna say new binary tree. Okay, cool. Now, what do I want? I want to insert certain data inside this tree that I've created as of now, the nodes that I've created. And how can I do that? Let's talk about that. What I'm going to do, I'm just gonna say binary tree dot root, and let's say I'm just gonna call this as a new node. Remember, we have mentioned this node out here, which is a constructor, and that's what we are creating. And let's say I'm just gonna call this as 10. Now it's gonna give me an error because as of now, I'm just gonna call this static. Again, this is the thing of the Java. Okay, and let's say I say binary tree dot root dot left is also gonna contain a new node. And let's say I keep this as 20. Okay, similarly, what I can do is binary tree dot root dot right is equals to new node, and let's say it contains data 30. Binary tree dot root dot left, let's say I create a new node, and let's say I contain 40 inside this. Now let's try and understand what we are doing. Okay, let's try and understand that first. What we have done and what we are trying to do is I've created up a node. I've created up one small little node, and I'm saying that this node is of the type root. I'm saying that I'm going to create a new node, and this node will contain the key, because this is what your constructor is saying, which is going to contain a key and going to map it to the key value of the node. So I'm just going to say that this is the 10. And right now, the left part and the right part, or the left child of the right child, I've kept it as null as of now. It's not going to contain anything. So I said null, null. And I said that the root will be the one which is going to point towards it. So I said binary tree dot root is containing a new node, which is going to have the key as 10, because this dot key is the key, and left and right are going to be the null. Make sense? So this is what I've done in this line statement. This is what I've done, and this is what's happening at the back end. If you're good to go till here, just give me a quick yes so that we can move further. Yeah. Now what I've done, I have said that I'm going to create a new node which is going to contain 20. So I said I have created up a node which is again going to contain 20, because it's after what is going to contain. Video got paused. Everyone can hear me, everyone can see up stuff. सबको सुनाई आ रहा है, दिखाई दे रहा है? Okay, cool. So what I've done is root, assign this root to a new node, saying that create a new node, typically contain 10 as a data inside this. Now, if you remember, this is the constructor that I've built, and now I'm calling this constructor out here. I'm saying new node, going to pass data. This is the key data, which is going to come here. It's going to assign this key value to this particular key, which is this 10, and going to say that this dot left and this dot right is going to be null. This is what I've done, and said that this node will be pointed towards the root. Make sense? Now, does this make sense? First line samajh aaya? I'm talking about the first line. Got it? Yeah. Now, what have I said in the second line now? What does the second line do? Second line said, okay, fine, do the same step again. Create a node, contain the data inside this, keep the left and the right as null, and assign this node where? To the root dot left. Where is root dot left? This is root dot left. Now what's going to happen? The root dot left is not going to be null anymore. What it's going to contain is basically going to contain this particular node. Got it? Samajh aaya what's happening? So this is why I'm saying root dot left. Now root dot left, which was this part, this is left and this is right. Root dot left, this root dot left is now going to contain new node, which is 20. Now see here, the power of Java is this, that you are using pointers, but without actually using pointers. Is it making sense what I'm trying to say? You're making use of pointers, but not specifying that these are pointers. This is what you call this as reference variables. Have you ever heard about reference variables before? Anyone who have heard about reference variables? Yeah, this is what these reference variables are. These are what you call this as reference variable. These are variables which are referring to another variable. Yeah, and here Java makes use of pointers without actually telling or saying, okay, fine, I'm gonna make use of this pointers. Make sense now? Right? And same stuff is being happening over here where I'm saying that root.write is typically going to contain one small little the small little one node, which is going to be this node, which is going to contain 30, going to be null, and your write is going to assign this as 30. Right? Then what I've done, what is the objective of this webinar? Talking about data structures, talking about competitive programming, maybe. Yeah, this is the agenda that we're going to talk about. We're going to see data structures live. That's what we're doing. We're going to see tree as a data structures. Tisha? Cool? Okay. Now, how many of you are feeling little lost because of the programming language? Be honest with this. How many of you are feeling lost because of the programming language, Java? Okay, so it's nothing to worry about. It's nothing to worry about. What you need is, you should be doing the same stuff on C and C++, and it's gonna work perfectly fine, right? The only thing that is gonna change is the syntax, right? And everything is gonna remain the same. And trust me, if you go around and have a look on C and C++, it's gonna remain the same. Logic is not gonna change. Okay, all right. Should we start? Should we continue now? Okay, so what I've done, let's talk about that. What we have done as of now, we have created up a constructor where I'm saying that it's going to be a structure called as, it's going to contain a key, which is going to contain an item. And inside that item, I'm going to contain two different sections, which I'm going to say left and which I'm going to say right. And then I'm going to assign these values when this constructor is called. Cool. And this is what I've done. Now the problem here arises, and this is one of the bigger problem. And this is where your interview questions begins from. Now we're going to talk about interview questions. The interview question is going to be, or let's talk about first the problem statement. Let's suppose if I have created up a node or a tree, something like this, where I'm saying that I have a tree which looks something like this. This is the root, which is 10, and I have left as 20, right as 30, and root.left is going to contain 40. This is the whole case scenario of your tree. Yes. But I'm saying root is going to be 10, root.left is going to be 20, root.right is going to be 30, root is going to contain 40 in the data. Cool. Now the problem here arises how to display this tree, because of course this is hierarchical. How should we display this? This is the problem statement. What do you think could be the easiest problem statement of all? Easiest problem statement, or maybe the easiest solution that you can think of. If I say that I want to display this tree, what do you think can be the solution for this? Guys, let's keep it interactive. सोचो जरा एक बार खुद से सोचो that if let's suppose if I have this tree and I'm just going to call this tree as, let's say, tree, this is the tree which is containing a root, a left, a right, and few other nodes inside this, and this is the whole complete structure of your tree. And if I say that, okay, fine, I want to display this tree, what do you think can be the solution for this? What do you think? In order, pre-order, post-order? Traversals. Okay. How many of you do not know about in order, pre-order, and post-order traversals? I'm going to talk about that. How many of you? No, I'm talking about the people who have no idea about in order, pre-order, post-order. Don't know. Fine. Cool. Not a problem. So this is the problem statement that we have. Though you have got the solution, but this is not the typical solution. And we're going to talk about, okay, how many of you actually know that use in order, pre-order, and post-order? Why not anything else? and what are the limitations of in order, pre-order, and post. And this is where actually your interview questions are going to pop up. Good for final year and third year students. Just listen to me very carefully. And even if you don't talk about C, C++, this is a conceptual thing that I'm going to talk about. Yeah. Why I'm saying that I need something like in order, pre-order, and post-order as orders. Why I'm calling these specific orders. What I can think of is this also. If I say that I can do something like 10, 20, 30, 40. This is also valid where I'm saying this is level 1. Let's say I call this as level 2. And let's say I call this as level 3. How about that? Can this be a moment where I can display my tree? Yes or no? This is one way of displaying my tree, isn't this? Yes? But there are few issues with this. What are these issues? Before we actually talk about this issue, let's talk about the orders which are prescribed. These are called as traversals. And have a look on these traversals, because these traversals are going to help you a lot in competitive programming. I'm going to throw you out with one of the questions and you'll see that, okay, fine. Yeah, these in order, pre-order, post-order traversals actually help you a lot if you're going to do something like this. If I talk about these traversals, what are these traversals for? These traversals are going to help you determine something. The three traversals that you have is what you call this as in order. There is something which you call this as pre-order. There is something which you call this as post-order. What these things are and why these orders are and what these orders do. These orders says that, okay, fine. If you have one node, if you look at this node, what I can do is I can have an order for this particular node, Typically, if you just see under this class node, what do you have? What you have a data, you have a left, you have a right? What does your in order say? In order say that if I talk about a node, let's suppose this is the node, I'm gonna call this as node. So your node is gonna contain something. There would be a left, there would be a right. This is what you call this as an in order. अभी बहुत डिटेल में एक्सप्लेन करता हूं, but just have a look on this. NLR LRN. What does this mean? These are very basic simple formulas that you can think of. What exactly is this? This exactly is telling where your node is. Just have a look on the node and just have a look on the name. In order means where I'm printing my node in between of the left child and the right child. Right? What do we have? We have three properties that I mentioned inside the node class, where I'm saying that my node is gonna get contained in middle of left child and the right child. This is what I'm calling this as the in order. In between of what? Left and right. Then I have something which I'm calling this as a pre-order. Pre means pehle. Pehle of what? The left and the right child. Post order, where I'm saying that my node is gonna get contained after my left and right child. Now, does these make sense? These are orders, and why these orders are we going to talk about that. But as of now, does this make sense? Is this cool? One thing that everyone would be feeling right now is LR. You'd see there is no order which is prescribed which is going to look like RL. Everyone can see this? ये question आया किसी के दिमाग में? Where I'm saying that I'm always saying LR, left, first left, then right. There is no order or any traversal where I'm saying the first is going to be the right and then the next is going to be left. Is it making sense? Keep that in mind. Always, where you have to go first is the left child, then the right child. Got it? Make sense now? Guys, responsiveness, little quick. Got this? Now keep that in mind, very important. First, always what you need to select is going to be the left child, then you have to select out what you call this as a right child. Make sense? Okay, now what I'm going to do, I'm going to make use of these orders. Okay, I'm going to code these orders. One order that I'm going to code is in order traversal. Okay, let's figure that out. I'm going to keep this hanging as of now right here. I'm going to delete this afterwards, but as of now, I'm just going to go around and code this. This code might look a little absurd to a lot of people, but just have a look what we can do if I want to do something like an order. Everyone is here. Should we go around and code this up? Let's have a look. What does this mean? Before I actually go around and start this up, may I know how many of you are not comfortable with recursion? It's fine because this is the best time where I can explain you everything. Yeah. How many of you are not comfortable with recursion? Cool, not a problem. Who else is not comfortable with recursion? It's fine. It's fine. It's completely fine. I'm going to explain recursion in very detail out here. Trust, mark my words. I'm going to explain you in very detail. Let's have a look. What are we trying to do? Let's first talk about that. What are we trying to do? We are trying to code something where I'm saying I have to find the in order of this tree. There is a tree which I need to find the in order of, right? What I'm going to do, I'm just going to create small little stuff when I'm going to call this as public. Let's say void. Let's gonna say pre-order traversal. Now this pre-order traversal is typically gonna contain the node root because you should know where I'm going to start from, yeah? Okay, so what I've done, I've created up a function called as pre-order traversal, which is of the type void, right? So it's not gonna return anything for you. And what does this take? It takes a root, which is the node, where you're telling that, okay, fine, this is where your root is, or maybe your tree is starting from. Okay. Now, one thing that you can think about which might go wrong, okay, is what if, abhi filhal ke liye samjho, but this is not the actual case. This is where I'm deciding up a base case. What if, just try and understand this. What if the root, which I mentioned out here, has got null? What then? What do I have to do if something like this happens? Root means this node, this particular root is the object for class node. No, this is the pointer. If you just have a look out here, this is this pointer which is pointing towards the start. If you remember that in the main method, I have mentioned that the root is the first key element which I have mentioned out here. Others, does this make sense now? And what I'm going to do, I'm going to pass this root when I'm going to call this function up, pre-order traversal. Okay. So everyone, what's going to happen if you find that your root is null? What does this mean that if your root is null? That means this statement never happened. Yeah? Yes or no? If your root is null, that means line number 25 that you have written where I'm saying that I've declared up a new node and I've pushed a data 10 inside this line never happened. Yes or no? Yeah? So what I'm going to do, I'm going to do the following steps only if my root is not null. Saying that I'm going to perform something only if the tree is not empty. Yes, that's what I'm saying. I'm saying that if my root is not empty, then I'm going to do something. Cool, got it? Just quick yes or no so that we can move further quickly, everyone. Yeah. Now what I want is from you guys, just have a look on this particular stuff just for one little second, and I'm going to explain you each and everything. Even for the people who don't know recursion, it's fine. I'm going to write few bunch of code and you're going to see that how typically can you make the best out of the recursion. I'm going to talk about recursion for a little while, but as of now, I just want you to focus out here. Now, what if I do something like, just like node head is not equals to null in the linked, it's exactly the same stuff where I'm saying that root is not equals to null, then I'm going to perform something. If you talk about the traversals from node to node, that's what you write. You said while the temporary variable, which is equals to head right now, when it's not equals to the null, because null is where you're saying that it's going to end. But here the null is saying that the root is not available. If the root is not available, you know for a fact that the tree is not going to get available. Got it? Does this make sense? Root is not equals to null means I'm only going to perform something. You're only going to perform something only if the tree is available. So that's what I'm writing. Perform only if the tree is not empty. Tree is not empty means that root is there already. Got it? Got it. Does this make sense? Okay. Now, what I'm going to do, just have a look out here. I'm going to do something only if that, if your tree is not empty, if your tree is not null, then you're going to do something. What are you going to do? You're going to go around with this NLR, which the formula says that go to the left, go to the node, and then go to the right. Right? Now let's talk about that, and we're going to have a look on in-order, pre-order, post-order traversal in very detail. But as of now, what I'm going to do, I'm going to say pre-order traversal. What I'm going to pass as a root is root.left. Just don't worry about what I'm writing out here. I'm just gonna say s out. I'm just gonna say root dot key, and then what I'm gonna say is pre-order traversal root dot write. Now, what does this mean, and what is going to do? Before we actually go around and talk about this, what I want you guys is have a look on few of the examples of tree and try and figure out that how you can make use of in order, pre-order, and post-order traversal. Okay. Now, what do I have and what do I want? Let's say I have a small little tree. Just everyone, just have a look. If I say I have a tree, something like 10, 20, 30, 40. Okay. This is the tree. This is a bare minimum tree that I can think of as of now. And let's say I want to find the in order traversal. And in order typically means says what? Says at first, go to the left child, then go to the right child. Oh, sorry. Sorry. Go to the node and then go to the right child, where I'm saying that my node is going to contain in the middle. Everyone is here. Just have a look. Okay. Where I'm going to start from? I'm going to start from the root because that's where my tree is going to start from. Everyone is here. Just give me a quick yes so that I can know that everyone is listening. I need your attention for a little while because I want everyone to know that how you can find your in order traversal as of now. Now, in for your in order traversal, what do you need? What do you need is wherever your root is. What do you need? Wherever your root is, you need to find the left child and the right child. I'm going to print that up, right? Now, just have a look on this root. This is the root. The 10 is the root. Now, if this is the root, what do you want to go? Where do you want to go first? First, आप लोग कहाँ पे जाओगे? You're going to go on to the left, right? Let's go to the left. If I talk about the left of the root, there is again one small little tree out here. Everyone can see this, which I marked 20, 40, 50. This 20, 40, 50. Got it. Correct है. Correct है. But as of now, for the people who don't know about in order, अब यहाँ पे अगर आप देखोगे, you're typically starting from 10, right? And where do you want to go? You want to go to the left. Everyone? Yes. But to the left of 10, there is something of a tree. Again, a tree. A small little subtree. Yes. And what you want to do is actually go around onto this tree and do the same stuff. Right? Now, what I can say that if I talk about this tree and this is the root, can I say that this is going to be the left and this is going to be the right? Yes or no? Just yes or no? Yeah. So for this 10 as the root, this whole little small tree is a subtree, which I'm saying, calling this as a subtree, right? Now, in this case, what I'm going to do, I'm going to take this tree as an example as the root. I'm going to say that this is going to be the left and this is going to be the right? And what I'm going to do, I'm going to make this left, right? Now, for this, there is going to be LNR. For this node also, there is something going to be NLR. For this also, there is going to be NLR. For this also NLR. For this also NLR. Right? Iska L abhi tak finish nahi hua. You are still rotating around the left part, right? And what you're doing is you have come to the left and you have mentioning this left now. इसके भी लेफ्ट में अगर आप देखोगे यहाँ पे भी आपको LNR देखना पड़ेगा. But if you come out here in this particular 40 as the node, you could see that 40 does not have a left. Yes or no? This 40 as a node does not have anything which you're calling this as a left. Is there any left for this 40? Is there any left child associated with the 40? No. Other people, is there any left for 40? No. This is where I need to stop. And what I need to do is I need myself to print this. This is the node which I need to print. So the first data which will get printed is going to be 40. And now you could see the left is done. The node has got printed. Now it needs to go to the right, right? And right, if you just see, does 40 have any right? Does 40 has any right? Is there any right child associated to 40? No, there is no child associated as a right for 40. So you could see the LNR of 40, it has printed the left child because it was already null. It printed itself and there is no right for this. And you could see for 20, he has completed the left section. So the left of 20, which was 40, has completed its LNR position. Does this make sense? So the left of 20 is all done. It's all finished. What do you need to do? Which node? The 20 which will get printed is going to be. Is the story okay till here? Quickly. Yeah. Now, 20 has completed its left, 20 has completed and printed its node. And what you need to do is go around onto the right of this tree and going to perform the same stuff. Now it's what's going to happen. You're going to come onto the right and you're going to perform LNR onto this node. If you talk about the left of 50, there is no left for 50. It's exactly like the 40. And then it's going to print itself, which is the node. So the printed stuff is 50. And then if you have a look on the right, there is no right for the it, right? So LNR for 50 is also done. Yeah. And you could see for 20, it has done its left part. This is the left part. It's done its own stuff. It has printed itself and it has also completed the right part, right? So for 20, LNR is done. But for 10, the left part has just completed. Yes? Yes or no? So first data which got printed was the leftmost thing, then the parent of that, then the right of it, right? And if I talk about 10, the L for the 10 is just completed because this was the small little subtree which you wanted to print. And this is printed in this particular order. Does this make sense? Abhi aage chale. Now the next step which is going to be printing itself. The node will get printed. And what will get printed is 10, right? Then it's going on to the right of the 10, which is going to be 30. And this 30 will have LNR again. So the left for 30 is nothing. The right for it is nothing. And then it's only going to print itself, which is going to be 30. Does this make sense? So I can say that this is the in order traversal of this tree, this particular tree, 10, 20, 30, 40, 50. This is going to be the in order traversal. समझ आया in order traversal? What does this in order traversal do for you? Does this make sense? For that, what I've written in the code is this small little code. This is the code. Have a look on this code. I'm saying is if the root is not equals to null, what do you need to do? You have to do the pre-order of root.left, system.out.println root.key, and pre-order of the root.right. Okay. And then you should get the pre-order traversal of any of the things or any of the trees that you want. Okay. एक बार इस कोड को रन करके देखें. Let's do a dry run for this and let's see that if something could happen. Are you ready? Should we go around and do a dry run? Dry run करके देखें इसका. Yeah. So what do I have is, let's say I have this tree, the same small little tree, 10, 20, 30, 40, 50. And the in order traversal which I was trying to figure out and which I just calculated was coming out to be 40, 20, 50 is a code in order. Yeah, the code for the in order. That's what we're going to discuss. So initially, जब मैंने dry run खुद से किया था for this particular tree, I figured out that the in order traversal. Yeah, so I'm doing the in order. That's what I'm saying. This is not pre-order. हाँ तो वही तो लिख रहा हूँ. It's going to be 40, 20, 50. Oh, 40, 20, 50. Yeah, 10 and 30. This is what's going to be. And that's what we found out as of now. Everyone? यही तो देखा अभी हम लोगों ने से थोड़ी देर पहले. But I said that this is going to be the in order. I'm only talking about the in order, not pre-order. I've given the name as pre-order in the code. You're talking about the code? Have I called this as pre-order? Oh, I'm so sorry. This is going to be the in order traversal. Okay, don't get confused. It's fine. My typo mistake. Okay, so if I talk about the in order is going to look something like this. Okay, now let's figure out that what's written in the code. The code says that what I need to do, I've created up a small little function which I'm going to write up here. I've said void and I said in order, which is going to contain a root. And this root is going to check something that if the root is not equals to null, what I need to do is I'm going to do again the in order of root.left. Then what I'm going to do is gonna write it cout as of now. what I'm going to do is see out what? The root dot key. And then what I'm going to do is in order of root dot right. And I'm saying that this code should typically work. How? Let's have a look. Everyone is here. Everyone's ready. This is the root. This is where your tree is starting. Everyone's here. Let's talk about that, how this recursion is working and how is it going to give you the exact same answer, which is this. Should we talk about this? Root dot node. Gaurav समझा नहीं मैं. Root dot node क्या हुआ? This is the left. This is the node. This is the key that you're printing, and this is the right that you're going. Gaurav समझ आया? ठीक है? Everyone is here. Should we start? Should we try to dry run this code? Let's try and understand that how this recursion is working. Shall we? Guys, yeah, let's do this. Now, just try and understand the recursion. For how many of you does not have any idea of recursion? Like, मतलब bare minimum idea भी नहीं है. मतलब like इससे पहले किसी ने पढ़ाया, but you actually didn't get it that how you're gonna use this. How many of you are very newbies to recursion? Okay. Okay. So let's take it from scratch and let's try and figure out that how this recursion is working. What recursion is basically where you're trying, when a function is trying to call itself, like in order, right? So you can see that the name of the function is in order, and you're calling the in order same function within its own body. And where this is where you're saying, okay, fine, this is recursion is happening. Now, what's going to happen? You're gonna see this in order function. I got confused when to use recursion, when to use the iterative approach to solve the problem. We're gonna talk about this. हम बात करते हैं अभी इसके बारे में. इसी का मैं आप लोगों को इसका एक iterative approach भी बताऊंगा. Has anyone worked on iterative approach? Anyone who knows the iterative approach of in order, pre-order, or post-order? Okay, Gaurav, how do you use it? What data structure do you use for that? What is the data structure that you can use in order to do in order, pre-order, post-order iteratively? Heap. Again, the same stuff. बात फिर घूम फिर के वहीं आएगी. Gotta try and understand your what do you call this as tree. If I talk about tree as a data structure is already homogeneous, or what I can say is non-linear. Yes, Gaurav? Yes or no? Tree is your non-linear. What about heap? Is heap a linear data structure? Yes or no? Is heap a linear data structure? Just yes or no, quickly, you're wasting time. Is your heap a linear data structure? Heap. Is heap a linear data structure? No. Does it going to enhance your algorithm, or is it gonna downgrade this up? Just try and just try and analyze this up. Are you getting? If I talk about the running case complexity, if I talk about running time complexity, what is the bare minimum running time complexity that you can think of if I talk about your iterative approach? Is it a good or the best optimal solution that you can think of using heaps? No, right? This is what we need to do. This is what we need to figure out that, okay, fine, which is the best or maybe the most optimal solution that we can think of. And we're going to talk about that in a while. But let's first try and understand the recursive part. Everyone is here. Should we talk about the recursive part? Should we talk about the recursive part? Cool. So what we have done, we have passed the root in the in order and said, okay, fine, this is where the tree is typically starting. And this is where when I do something. What we're going to do, we don't know. This is the code. What we're going to do and dry run this up. But the first thing that you should know about recursion is one of the concepts in any of the programming languages which are not used in industries, which is not used in industry. How many of you have learned the subject called as DAR, Design and Analysis of Algorithms? Anyone? Who might be in second year or maybe third year for the people? They might have come across with the subject called as Design and Analysis of Algorithms. How many of you are from third year? Third year people? Or maybe second year people? Padha hai Design and Analysis of Algorithm? Now, in that case, in design of analysis of algorithm as a subject, what does it tell? What does it say? It says that for any code or any algorithm that you go across on the internet or anywhere, it typically has two parameters on which you can judge that particular algorithm. What are these? these algorithms are judged on the basis of the time that it consumes and the space that it consumes. That's what you call this a space and time complexity. Yeah. So the space complexity is that how much space is required in order to run that code up and how much time is required in order to complete that code up, right? So in this case, let's time that up. If you're using recursion, just have a look at how much space and how much time that does this consume and how it's going to help, okay? It says that for root, the same piece of code is going to run. This small 3 lines of code is going to run for everyone. I'm going to make it 4 lines. Just have a look. So there is a copy of the code, which is going to call this as in order. And it's going to contain these 4 lines written out here. And this is going to be the case for all the nodes that you talk about. And this is the worst part about recursion, where I'm saying that everything that the code is going to happen simultaneously for all the nodes that you've written. Key point number 1, if you're making use of recursion, keep that in mind that every time you're going to make use of recursion, the same line of code going to get running all the time, over and over again. Does this make sense? Now, for this, if I talk about all the nodes, what's going to happen? This if statement, which is the first line, and these 3 statements which are written inside these if statement are going to run over and over again for all the nodes. Okay, and this is going to happen for all the nodes. So if I talk about space, is it optimized? Just yes or no. What do you think? If I talk about just the space part, is it optimized? Yes or no? Just have a look on the space part. If I talk about the code being displayed over and over again, the same code over for all the nodes that you're coming up across on the tree, you could see that this is not the optimal solution. This is definitely not the optimal solution. We're going to talk about the optimal solution, but let's figure that out how this is going to help for you. Now it says that if the root is null, is the root null? If I say root should not be equals to null, is the root null? The root is pointing somewhere. So is the root null? No, root is not null. First line got checked. Now it says if the root is not null, then the 3 lines are going to get checked. What? In order of root dot left. Now the first line says, okay, fine. If the root is not null, do you have a left? So does 10 has a left? Yes or no? Does 10 has a left? Yes, it has. And what it is, it's going to run the piece of code which is written for 20. The 3 lines of code again, it's going to run for the same. Now, right now, the root will get changed to root.left because the root is root.left. The code for this 20 is going to get running. The code for this particular 20, the value of this root will change to what? Root.left, because this is what you're checking. This is the line of code which is working right now. And if I say that if this root, now this root is replaced with what? The root is replaced by root.left. So if I say if the root.left is equals to null, is the root.left null? Is 20 null? Just no. Is 20 null? No, right? So 20 is definitely not null, right? Keep that in mind that 10 ka first statement, which is in order root.left, is still not completed. It's still in progress. It's still working on the left part, right? And now what's going to say that, okay, fine. If 20 is not null, why don't you go around and have a look on your left part? And that's what it's going to do. It's going to come here. And the value is now root's value is going to now get changed to root.left.left. Now it's going to come here. It's going to say, okay, fine. If the root.left.left, which is 40, is it null? Is 40 null? No, it's definitely not null, right? So the first line got implemented. Now it's going to say the second line. It's going to say, okay, fine. Why don't you go onto your left part? Which typically is definitely null. It says is, yeah, but it says go to your left. Is it null? So it says if root is not equals to null, but root is definitely null, isn't this? Root is null. Now iska left, where I'm saying that it needs to go onto the root.left, right? It needs to go onto the root.left. So in order of root.left is now null and nothing's going to happen. Yes, it's going to return back from there. Now it's going to go on to the second line. बात समझ आ रही? इतनी line समझ आई that what I said for 40, the second statement is going to be null and nothing's going to happen. Yes or no? Yeah. Now it's going to come onto the second line. And what does the second line say? That it said, okay, fine. See out root.key. And what's the root? The root right now is root.left.left. And what's going to happen and what will get printed? The printed stuff will be root.left.left.key is the thing which is going to get printed. So root.left is 20, .left is 40, and the 40 ka key is definitely 40. So the first statement which got printed is 40. Does this make sense now? In code. So I said cout root.key. Cool? Got it? समझ आया क्या हुआ अभी यहाँ पे? Now in the next statement, because this statement is done, it says find the in order of root.right. Now if I talk about this particular root, do you think that the right of this 40 is going to be something? It's definitely null. Yes or no? Guys, yes or no? The right of this is null. So there is nothing to get printed on, right? Now, if I talk about this 40 has completed its piece of code and it's going to submit the solution to 20, right? Because that is what 20 initiated. 20 said, okay, fine, I need to look on the left part, right? And now I can say that the left part is done. It's done and completed. The left part is completed. Now, what I'm going to do is I'm going to run the next statement. And the next statement said, let's see out root.key. And this root is definitely is what you call this as 20. Samajh aaya what happened? Did you understand what actually happened right now? This is what you call this as backtracking in recursion. This is what you call this as backtracking. Samajh aaya, guys? Just a yes or no so that I can move further quickly. Did this make sense? Chalo. Now, in this case, what I'm going to do, I'm going to say that, okay, fine. I have printed myself. Now, what I need to do is need to go to the right, right? Right is still not executed. So I need to go on to the right. Now, this is the right. Now, the right says, is the root dot left dot right null? Is 50 null? Quickly, yes or no? Is 50 null? No. So it executed the first stuff, right? So it said, okay, fine, I'm not null. What I need to check is 50 is left. Is 50 is left null? Is 50 is null? Is 50 is left null? Yes. So it got executed. And it says the next line that you need to execute is print yourself. Okay, so it said, okay, fine, I need to print myself, which is 50 again. So it printed itself and it said, okay, fine, I need to look on the right part. Is there any right part for 50? No. So it does not need to do anything and it's completed its process. And for 20, it's going to return the statement back and 20 is going to be happy because it's executed all the 4 steps, which is look into it, look on the left, print itself, and look at the right. And you could see that this left subtree has been printed now. And this left subtree is going to submit the data to 10, which is going to backtrack. And it's going to say 10 is going to be happy. Okay, fine. Yeah, my left portion is all done. Is it making sense? Samajh aaya? Now what's going to happen? Everything is going to get back to 10. And it's going to say, okay, fine, I need to print myself. I need to execute the next statement, which is printing myself. And the next data which will get printed is going to get 10, right? And then what's going to happen? Then it's going to say, okay, fine, now I need to iterate on to my right. So it's going to come to my right. So right's going to be like root.right. So is root.right null? Is 30 null? Quickly. No, it's not null. Definitely it's not. It's going to say, okay, fine. Do I have a left? Does it has a left? Is 30 has a left? No, it doesn't have a left. So this command got executed. And then it says, okay, fine, go around and print yourself then. So it said, okay, fine, I'm going to print 30, right? And then what's going to happen is it's going to print to the last statement, which is right. Does it has a right? No, definitely not. So it's also executed. And you could see that everything is all done and all sorted and everything got printed as a thing that we expected. And this was a thing that we dry ran, which is 40, 20, 50, 10, 30. And this is what your function is going to return. Is it making sense now? Recursion samajh aaya that how this recursion is working. But how is it going to go around all to the nodes? Going to ask for this data. It's going to ask and iterate this way. But don't you think that this is really, really tough and really, really a lot of code to execute? Isn't this? Yeah. But let's go around and test this up for a while. Let's go around and test this in the same case. So I'm just gonna go and run this up. And how I'm going to run is going to create another function. It's going to say public void in order, and it's not going to contain anything. I'm going to call this function back, which is in order traversal. I'm going to pass this root, right? So that whenever I call this in order function, I do not need to pass the root when I call this in the main function. What I do is say binary tree dot in order, and let's see what happens if I do something like this. Okay, so let's go and run this. Just the binary tree. You could see that we got the same result, which is 40, 20, 10, 30. This is what we were expecting. 40, 20, 10, 30. Okay, so this was the thing. Okay, so what I'm going to do is going to decide one another thing, which is going to be the 50 part. The 50 is onto the right, right? So what I've done is the left, right. Just give me 1 second. Left, right. Oh, open this up. So what do we have? 10, 20, 30, 40, and it's onto the root dot left dot right, right? Root dot left dot right. Root dot left dot right. Root dot left dot right. Root dot left dot right is the new node. Let's say this is 50. Okay, let's go and run this up, and let's see. We typically should get the same results that we were expecting, which is the same thing. Let's see that up. You see 40, 20, 50, 10, 30. This is what we were expecting. Yeah. So 40, 20, 50, 10 and 30. Got it? Cool, eh? So yeah. So I guess this makes a lot of sense. Okay? Guys, is it okay? If you're good to go till here, just give me a quick yes so that we can move further. Yeah. Now, there are other traversals as well. We just had a look on the in-order traversal, right? If I talk about how to create the pre-order traversal, how about that? Let's go and build this up. And let's say if I do public void, let's say pre-order traversal. So what the pre-order traversal is going to be? Just think about it. If I talk about pre-order traversal, which should come first? I say if the root is not equals to null. What do you think about pre-order traversal? So what's going to come first? What should be coming first? Right? So first, what you need in the pre-order is to print the data first. So this line is going to come first. This is this. Then you're going to go on to the left, which is this part, which is pre-order traversal should be to the root dot left. And then what do I need? The pre-order traversal to root dot right. Yeah. So if I talk about pre-order traversal, this is the small piece of code that you actually need to remember. Yes, everyone, isn't this? And similar is the case with the post-order traversal as well. So I'm just going to do what? I'm going to copy this up. I'm going to paste this. I'm going to save this as post-order traversal, where you're going to go on to the left, then you're going to go on to the right, and then you're going to print the data, right? And this is what you're going to call this as post-order traversal. Post-order traversal. I'm going to call this as post-order traversal. I'm going to call this way. Make sense? Code samajh aaya? Is the code making sense? Quickly, everyone. Yeah? Okay, cool. So this is how you can typically implement the binary tree. Now the session is pretty much over, but we haven't covered out BST. Okay, anything that you want to ask as of now for the things that we have covered in the session? Anything that you want to ask? Anything? Yes, no. Quickly. If you're good to go, just give me a note that you do not want to ask anything. If you have a doubt, let's talk about the doubt first. Everyone, I'm asking it to everyone. Why does list starts from 0? Which list are you talking about? The arrays you're talking about. Typically arrays is what you're talking about, Harshal. When to use recursion, when to use iterative solutions. Very honest, we're gonna make use of. Okay, let's talk about. Okay, abhi baat karte hain uska. When you talk about recursion and when you talk about the iterative approach, that typically depends on what kind of like an application that you wanna build. Okay. Um, anyone has been into web development, maybe React or maybe Angular or maybe JavaScript and stuff? Anyone who have been into full stack development or maybe React and Angular and stuff? Not talking about Flutter, for the people who have been into it. Okay, so in that particular case, what if you write something in React? Let's say you are doing up, okay, so you're doing a callback function, you're creating up a callback function, or maybe in Angular, creating a component. And in that component, you're saying, okay, fine, I'm going to build this component. I'm going to do something on the click of a button. You do a event, and then you say, okay, fine, this event binding is a recursive function. How about that? Will it going to work? Is it going to work? Think about this, that the recursive for anything is clicking onto a button, and that button is actually opening 5 or 10 minutes later. How would you like it? Let's talk about Facebook. Click onto friends, and your friends page basically after 5 or 10 minutes. How about that? It's really, really bad, right? So actually, when you talk about an iterative approach and when you talk about a recursive approach, this is, you have to decide depending upon how much time you need to give on to the code. When you want your codes to go on a faster pace, you will have to come across with a, you could say, a iterative approach. But if code, the length of the code is what you need to min on, recursion is the best approach that you can work on, right? Have you ever heard about dynamic programming? Have you ever heard about dynamic programming? Anyone ever heard about dynamic programming? I'm going to give you one small little example. I'm going to talk about one of the very famous question. I don't know why interviewers love this, but they love this question on arrays, and the very basic question. Everyone is ready. I'm going to tell you one very important question, which will definitely will come across if you're going to sit on any of the placements, let's say, and this will definitely pop up. This has been shown in TCS. This is being seen in Cap. This has been seen in Wipro as well. So that's one of the questions that I'm going to talk about. Everyone is here. Minimize the space and time complexity. What are the tools that we can use to minimize space and time complexity? As I said, make use of dynamic programming as much as you can use dynamic programming. Dynamic programming gonna help you a lot. Now, just go for DP. DP is gonna do everything for you. If you have a recursive code and you want to go around and do that and change that recursive code into a iterative code, DP is something that that's gonna help you. Have you heard about DP, dynamic programming? Will there be any sessions? If you want that, definitely we can have this. If you want these sessions, we can have these sessions. Yeah. But as of now, I'm just going to tell you a few different things. Okay. What are these few different things? Let's talk about that. Okay. We can have these. Definitely we can have these sessions. Okay. But as of now, let's make the best out of these sessions. Thoda sa date bhi ho jayega, it's completely fine. Okay. I'm going to tell you one problem statement. And this is very advanced. Not advanced, but this problem statement I've seen this like a lot of times. You want to see this problem statement? Like, okay, should I tell you the problem statement? You're going to code it for yourself. I'm going to tell you the logic that how you should think about if you're a competitive programmer. But as of now, I'm going to tell you one small little problem. Let's suppose we have an array. Okay. Let's say the name of the array is, let's say, and the array typically contains, let's say, 10, 20, 30, 40, and let's say 50. Okay. Now, what do I want? Has anyone heard about subarray? Subarray pata hai kisi ko? Anyone who have heard about subarrays? Yeah. So if I talk about the subarray of this particular array, what could be the subarray? Not talking about the maximum subarrays. I'm going to talk about the possible subarrays. Can I say 10 is a subarray? Can I say 10 is a subarray? Yes. Can I say 10 comma 20 is a subarray? Can I say 10 20 10 20? Can I say 10 20 30? Yes. If I say 10 20 30 40, yes. And if I talk about the whole array, which is 10 20 30 40 and 50 itself, yes, this is also a subarray. Yes. Yes or no? So these are the 5 subarrays that I can talk about, which are starting from 1. These are all the subarrays which are starting from 1. What about the subarrays who are starting from 2? So the subarrays could be what? 2, 2, 3, 2, 3, 4, 2, 3, 4, 5. Yes? Can I say these all these 4s are also subarray? Yes or no? Can I say this? But all these subarrays are all ones which are starting from 2. Yes or no? Check. Now, if I say I need the subarrays which are starting from 3, so I can 3, 3, 4, 3, 4, 5. These are all starting from 3. How about the subarrays which are starting from 4? 4, 4, 5. These are starting from 4. Starting from 4. How about the subarray which is starting from 5? This is a 5 itself. Okay. So this is the only subarray which is going to start from 5. If you're good to go till here, just give me a quick yes. मैंने अभी problem statement कुछ discuss नहीं किया है. I have not discussed the problem statement, but I'm only talking about the subarray part. So these are the subarrays. These are the possible subarrays that you can think of. Yeah. Now, how about let's talk about the problem statement. Let's discuss the question that you have, and the question says, find the number of possible subarrays, or maybe not, or maybe just gonna say, let's say gonna complex this up. Let's say find the sum of all the possible subarrays of the given array. Let's talk about this. कितने लोग अभी solution निकाल सकते हैं? Just give me a yes or no. I do not want the solution. Just say yes or no. How many of you can find the solution for this? Find the sum of all the possible subarray of the given array. And this is the given array. The array contains the data from 10 to 50. How many of you can do this question, this particular question, finding the sum of all the possible subarrays of the given array? Just yes or no. I do not want the solution. Just yes or no. Other people? Okay, can try. Now, how about if I do something like n big O of 1? Now, how many of you can do this? In constant time, if you want to do the same problem statement in constant time, saying that you want to do this in big O of 1, big O of 1, constant time. How many of you can do this? Let's talk about it. And this is the problem. This is the complete problem statement. The problem statement is to find the subarrays and return the sum of all the possible subarrays. Should I give this to you on the assignment? Oh, good. Very good. So should I give this to you on assignment part, or should I explain you this in this? Should I explain you? Explain little. Explain. So I'm just going to explain you. But for the rest of the session, if there would be some other sessions, we can have a discussion on few different approaches as well. Okay. If you just have a look on all of these subarrays, you can just see that for the first set of subarrays, which was starting from 1, the count was 1, 2, 3, 4, and 5, right? So all the possible subsets which were coming from starting from number 1, from number 10, were 5. What if I talk about these? Starting from 2, the number of subsets which are starting from 2 are what? Number of subsets. The number is what? The count of the subarrays which are starting from 2 is, everyone, 4. right? The number of subsets which are starting from 3 are what? Quickly, just be a little responsive, really quick. Yeah, 3, then it's going to be 2, then it's going to be 1. So if you just have a look on the problem statement, it said find the sum of possible subarrays, right? Sum of the possible subarrays. So if you add them up, can you see this accumulates the formula of n into n plus 1 by 2, right? Where n denotes the size. Yeah, so you could say that it could be 5 into 6 by 2, which is going to give you what? 15, I guess. 5 6 are 30, 30 by 2, it's going to be 15. And if you just count these up, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. And this is how you can do the problem statement in big O of 1 time. How much time does it take to actually evaluate n into n plus 1 by 2? Big O of 1, right? Got it? Got the solution? That how you can cater onto the solution? Does the solution make sense to everyone? Everyone, does the solution make sense? There are a lot of problem statements, that you can come across. And if you want, we can have these sessions and we can have a look on it. Okay. All right. So as of for now, I'm going to wind this up because, of course, this is a little late. But how did you like the sessions? How was the session? Did you learn anything out of the session? That's the main question that I should ask. How many of you learned something? Can you send me the code? Definitely, I can. Definitely, I can send you the code. I can definitely send you the code. How can I send you the code? How can I do that? Okay, so how can I send this code? Node plus plus? Don't know. I do not use that. That's I've never used that before. Pass in the chat. So what I can do, I can just push this up onto the Git, and you can go around and have a look on that. How about that? Yeah, GitHub. Should I push this onto the Git and give it to you? How about that? Yeah. So let's do that. I'm gonna take 1 second of yours. I'm gonna go onto my terminal. I'm gonna push this whole webinar onto the thing. What I can do is I can go to my desktop, or maybe just this is gonna take time, right? This is iOS. Yeah, I work on macOS. Yeah, I work on macOS. So what I can do is I can push this code. I'm gonna go onto my desktop. What do I have is webinar, right? Let's say git init. Git init, and just gonna say git log. There's no commits, right? Git status. And add all of these files. Git add. Gonna go up status. Everything is fine. Git commit. First commit. Right. So if I just have a look on the log, tree would be done. Cool. So what I need to do is go into my GitHub. I'm quickly gonna share you out with the code as well. I'm gonna create a new repository. I call this as SRM webinar. I'm gonna create this repository real quick. Very bad. You don't like working on macOS? You don't like working on macOS? It's fine. Just personal choices. Access rights. Okay, not a problem. Import the code. It's not friendly. Not like that. It's not friendly. See, typically I'm an iOS developer, so I have to work on Mac. So Cannot do anything for that. For that matter, I cannot do any extensions. But this is gonna, yeah. So maybe let's go into my repositories. Just 1 second. I'm just gonna. मेरा पता नहीं शायद I'm working on beta versions, so this is giving me a little hard time. इसमें ये चल क्यों नहीं रहा है? I'm gonna push the code. What I can do is, sir, send it to us. We can provide it to students. Send it to us. Yeah, sure. I can send it to you. That will make more sense. So you can contact me up. I can create on. Let it be. So def is send it to us. We're gonna store this CodeChef. Okay, cool. So how can I contact you guys? Any idea? So how about if I share this to Anurag? Anurag can go around and share this to us. Will it be fine? Will it be fine? Okay, cool. So what I can do is, as of now, you'll get the code. You'll get the code. It's fine. Paste the code in the chat box. Oh. What rather I can do is, rather I should yeah, share it in yeah, that's what I'm going to do, because I'm not pretty sure that if I'll be able to share the code definitely on. No, I don't know. Of course I can do that, but as of now, I'm not pretty sure if I can share it out with you, because let the officials do the work. I need the management to get involved in this. Will it be okay? You'll get the code eventually. Definitely you'll get the code. There's nothing hard and fast in that. Okay. I need the officials to get involved, because at the end. All right. So one thing that I want you guys to have a look on is CipherSchools. So I'm just going to tell you a little bit about CipherSchools. So typically, I'm the head of software development at CipherSchools. Okay. I take sessions on competitive programming, data structures, full stack development. I've been iOS development as well. I know a lot of frameworks. I'm comfortable with React. I've taught Angular. I've taught Spring Boot. Has anyone worked on Spring Boot? Okay, so you're not Java developers, right? I'm pretty sure you're not Java developers. Ionic is completely different. I have worked on Ionic, but that domain is completely different. I'm just right now talking about Spring Boot, Node.js, all of these things. Have you worked about this? There's a huge marketplace that is going on if you talk about full stack development, right? Node.js, you can talk about Vue, you can talk about all of these things, right? Server side programming, client side programming, competitive programming. These are all these buzzwords which are coming over onto the cross, right? We in CipherSchools have these courses for you guys. Yeah, you can go and we deal into industry standards, right? This is what I can assure you. There are a lot of courses if you want to go get enrolled into full stack development. That is also something that you can totally do. Maybe competitive programming, maybe data structures, maybe learning new technologies like Java. What about FTC? No, not FTC. We typically focus on the subjects which these fortune companies like FANG are typically looking for a candidate, right? For example, you should be good at data structures and competitive programming if you want to go around there, right? You should be, if you want to go and work for Google, you should be knowing Angular if you want to go around as a full stack developer, right? Because that's the framework for Google, and Google definitely wants something like that. Yeah. What I want you guys is, just give me one little second, huh? I'm gonna stop the share because I need you to provide you with something. I'm gonna open my WhatsApp for a while because I need to copy a link. One small little thing that I need to do. I'm going to pull this up. There is a small little feedback form for you. You can go around and fill this. Depending upon if you like the session, you can go around and do that. Okay, just give an honest feedback. There's nothing hard and fast. Just go around and give an honest feedback. And this is for you, right? You can go around and have a look. It's not really messed up. That thing is like completely different thing. Okay, it's nothing to get messed up. I'm being very serious. I have sat on the coding interviews for Google. I cleared that out. I'm not don't want to link for GitHub. My GitHub. So if you can share me out on for Arun, but because that's not my official GitHub, but because my official GitHub is with Apple, so that's completely different. I do not share GitHub, but for the GitHub that I use for students is you can go around with github.com/Arun Kudial. This is the spelling. You can go around and do that. Oh, so chat section got privately. I'm gonna share it to everyone if you need that. Yeah, it's /Arun Kudial. You can go around and have a look on that. So I can post it on this. You can also follow me on LinkedIn as well, right? So if let's say someone is looking for me on LinkedIn, you can also go around and follow me on LinkedIn. Okay. So as I was talking to you about CipherSchools, so CipherSchools is emerging company which is following on to the things for students, because we want these students to get placed into companies like FANG, and that's the goal that we are aiming for. We cater on to all the industry standards. We talk about the things which are required in these companies, like competitive programming, data. If you want to go into full stack or maybe machine learning and artificial intelligence, that is also something that we cater on, right? So if someone is interested, you can go around and follow me on LinkedIn or get me added as a connection if you want. Completely up to you though. But if someone wants that, you can go around with that. So as the name goes, Arun Kudial, you can go around and follow me on LinkedIn. And what else was I showing you? CipherSchools. So you can go around and have a look on CipherSchools.com, CIPHER. I'm just going to share you out with this as well, right? So you can go around and have a check that what are all the courses that we offer for. And definitely we can, if you want, we can have a look on these free sessions as well. If you want, we can go around and talk about few other things as well over a period of time. That is also something we can do. But if you want the course which you really think that's going to help you get a job in these companies, we're definitely going to help you. There are great instructors with us who have and who were working with these fan companies like Google, Amazon, Apple, Microsoft. We instructors are been to a part of this journey with these awesome companies. We know how the work is done out there, and we're going to teach you, as I said, on industry basis, right? I've been a part of Apple for a really long time, and I know how the things are done out there, right? So as I said, if you want, we can arrange these sessions for you. Of course, you can go around onto CipherSchools.com and you can go around and have a look on that. And what about Google? There is an instructor who has worked for Google. He's into artificial intelligence. He takes the sessions for artificial intelligence and machine learning. What about Google? So I cracked Google as well, but I didn't go there because I always wanted to work for Apple. That was one of the kind of like the dream job that I have. Even if you want to have to throw, okay, why? I don't know why. Um, uh, okay, so okay, Gaurav, why are you passionate about Google? If I talk about that way, so I do not have an answer for why, because I like that company. I've been working on these devices for a really long time. So I thought, why not go around and work for these companies? So I got into Google, but I didn't actually go around and serve Google. Never just for a day. But yeah, I worked for Apple. So I'm happy with that because I always. Do you want to know that if you want to ask any tips and tricks that how to get into all of these companies and what you should prepare, you can talk about that. How long have you worked for Google? I've worked for Apple for 2.5 years. I'm still associated with Google though, Apple though. I'm still associated with that. And we are the instructors who take sessions for this. Feedback form. Did I not share the feedback form? I shared the feedback form. Oh, so it got misplaced. Copy this up. Got everyone. Yes. Here's a feedback form. So you can go around and fill this feedback form and be honest with the feedback form. It's completely fine. Yeah. So anything that you want to ask, I'm keeping the doors open. If you want to ask anything or anything regarding any of the things that you were curious about to know, you can talk about this. Anything. How to get into it, what should we study, what should we be more focused on, and what should we do as a for maybe third year or final year students, what should we do and how to get into all of these apps. How was your experience after college? My experience after college really taught me a lot. uh, how to get a tech job on Google. Just give me 1 second. My experience after college was really good, I'll say. Plus really I've learned a lot. There are few things for people who are about to go in the industry. First thing, there is no friend, the word friend in the industry. Everyone is your colleague. Just maintain the decorum of the colleagueness. Yeah. And the second thing that I've learned is mind your own business. Right? So just concentrate on your work. Don't go around and do all of these different things. Just focus on your work and you'll be good to go. Right? How to get into tech job at Google. Okay. So there are a lot of coding tests that they conduct, right? One way of doing this is actually sitting onto these coding platforms and write the test for Google, and they can go around and do this. Second thing is that you should have a source as in like for the people that as developers that are working at Google, and you can ask their recommendations as well. They bless you with the recommendations. Okay. Referrals at Google, yeah, you can go around and have a look at referrals at Google as well. The third thing that attract Google people a lot is your resume. Yeah, if your resume is good enough, you can go around and Google can actually call you back talking about, okay, if they can schedule the interview for you, right? But again, as I said, your resume should be really strong. You should be very fond of the things that you write, and you should be very clear. And there are YouTube videos for this. If you go around on YouTube and have a look on one of the channels which is called as Life at Google, that's a dedicated channel made by Google for you guys. Yeah. So you can go and ship your resume and they can call you back on that. What all will be taught in data structures. So data structures basically start from scratch, talking about Java as of now, because Java is what we teach in competitive programming, because that's not exactly C and C++, not so background as C++, but not as advanced as Python. So we teach data structures in Java. So we talk about Java for a few instances. Then we move on to very basics as arrays, and you could say ArrayList and all of these things. Then we go around on with you could say to how recursion works, how we can make use of recursion. And then we talk about these data structures like arrays, ArrayList, lists, linked lists, stacks, queues, hash maps, trees, BSTs, and all of these things, right? Where can we learn more about competitive programming? See, to be very honest, you cannot learn competitive programming from anywhere. If you're good with solving problem statements, this is what you all need to do. You cannot learn anything. You can think about this, you can find the solutions from the internet, but you cannot learn competitive programming until and unless you do not practice it. So practice is the only way you can learn competitive programming. What should we study for artificial intelligence? If you go around with CipherSchools, you do not need anything, not even one single line of code written on Python. We start from scratch. This is what is the main agenda. We cater onto the students who have never who are really interested in getting into all of these things but actually have no knowledge. That's also going to do all the things. Okay. Contributing to open source, will chances are yes, a lot. If you have been working on open sources, Google is definitely going to look into your interviews. And I'm going, okay, so I'm just going to show you. Okay, I should not open YouTube as of now, but there is one channel which is called as Life at Google. They have specifically mentioned that if you have worked on open sources, the chances for your getting recruited as a Googler is more as compared to any of the other. C++ would be enough for competitive programming. If you're just saying as a programming language, yes, more than sufficient. Just knowing one programming language can get you into Google. There's nothing, they do not want you to know thousands of languages. Just one language, you should be comfortable with that language. Yeah. The duration of the course. The duration of the course is typically 1.5 months to 2 months. This is what we talk. But I don't know of Java basics. We teach Java basics from scratch, as I said. We talk about Java, what Java is, why Java is platform independent. What do you mean by platform independence? What happens when you write something? What is stack memory? What is heap memory? This is all taught. The syntax is all taught over the period of time. So you do not need to worry about anything. What is the exact roadmap that we should follow to crack these interviews? Like where to prepare questions or for stuff like that. Okay. Um, One thing you should be very clear about is uh, that if you talk about the roadmap is very, very simple. Okay, so this is for everyone. Okay, this is for everyone. Just listen. Step number 1, select your favorite programming language, any programming language that you want, any programming language. Select that programming language, learn the basics of that programming language. Then what you need to do is take data structures. You should be able to write data structures in the programming language that you chose. Step number 3, go around, look for competitive programming questions in the platforms like CodeChef or HackerEarth, HackerRank. These are good platforms where you can find quality questions, right? And you can go around and solve these up, and you can get all of these, and you can exercise these up. You can code them up. The more you're going to code, the more it's going to help you out. So this is the whole roadmap. And then if you want to crack these interviews, you should be very, very clear on competitive programming, because that's all they want. That's typically all that they want, right? How to get off-campus placement for Google or Apple. As I said, you should be either having referrals. If you have referrals, the person can refer you up. Second thing is okay, so I'm going to tell you about Apple. Google, I have literally no idea. You can go around and have a look on for Google. Google Clay, typically there is also one small little tab out there. What is your advice for students? Just focus on data structures and competitive programming. That's it. Now, if you're just gonna scroll down to this apple.com, there's gonna one small little thing that you're gonna see here, which is called as jobs at Apple. Where is it? Apple for Business, Apple Store. Where is it? See Apple newsletter. Oh, have they removed the tab? So here's one of the tabs that you can, this is the tab of jobs that app. So you can just have a look on this. Okay, so if somebody is interested for Apple, you can go around and submit your resumes out here, right? So they have everything that you need, right? So you can select out on there, you can submit up your resumes. If they like their resumes, if you like your resumes, they're gonna call you back. They can schedule up their interviews, and you can go around and have a look on that. What's the one advice that I want to give it to third year students? Just focus, just focus on data structures and competitive, nothing else. Everything is going to fit in place. If you're good with coding, if you really love coding, everything is going to go and fall in place. Don't worry, everything is going to be fine, right? And again, if you want, you can join these courses. We're going to help you out throughout the course, and even after the course, you get these videos, which is in the classroom portal, and you get these classroom portals forever. You can go around and have a look on these. So I'm just going to show you out one small little classroom that I have already. This was the batch which I took with LPU, Lovely Professional University. Yeah, lifetime, forever. You can just keep these videos forever. So this was one of the things. So this is the classroom, and you could see we talked about, this is little you could say little high tech, because these are the frameworks which I was teaching them, which was Angular. We also had a look on whatever you want. So it's like, it's completely fine. I even sometimes speak in Hindi. I sometimes even speak in English. So it's fine. So this was basically the full stack development course. So this is the kind of like the classrooms that you get, right? So you can get these materials, you'll get these videos, which are typically live recorded, and you can have these forever with you whenever. And this is stuff, right? You get these videos. You also get these certificates, which are official certificates from CipherSchools regarding the same, about your course completion. This is what you get. The classes are live. That's more important. The kind of like the live sessions that we are working on right now. This is the kind of like, do we get free MacBook if we get at Google? Yeah, you get free MacBook, you get free phones, you get free a lot of things. You get free travel, food, everything that you can think of. Spring for backend development. Do you use primarily Spring Boot for backend development? No, I work on Node.js. First of all, I'm not a web developer, so I'm not into too much of backend. But I can work on Spring Boot. I can work on Node.js. I can work on Vue. I can work on pretty much any. I can work on PHP. I can work on almost almost these platforms. Anyways, I'm typically an iOS developer. I work on Xcode. Advice for second year students: this is the best time. Second year and third year students, I'm being honest. I don't want to manipulate you, but I'm just gonna say second year and third year students, you have an ample amount of time. You can do anything, and you just realize that the moment you'll get enrolled, you'll just figure that out, that there are so much things to learn, and you can actually learn a lot of things in a month, and you can actually make the best out of it. I'm being very serious with this, right? And you can make the best out of it. And the advice for second year student is just focus on 3 subjects. Data structures overpowered? Not exactly. And you can see, and you can go around onto all of these web pages. Then they'll typically tell you that competitive programming is one of the easiest ways to get into the industry. I'm being very serious. And you can go around and have a research on this, right? 3 things and 3 subjects that you should be very good on if you're aiming all for these fun. First is, of course, data structures and competitive programming. Second, operating system. Third, design and analysis of algorithms. These 3 subjects can typically take you from level 1 to level 100. I'm being very serious. If I talk about jobs, these 3 subjects are going to take you, I don't know where. Like DBMS, not exactly needed. Not needed. Because we do not work on DBMS anymore. We work on NoSQL databases like MongoDB and stuff like this. So DBMS not makes any sense for the world that we are living in today. DBMS and SQL is no more anywhere in the use. You actually do not need them anymore. Anything else that you want to ask? What do they ask OS? Okay, so there are a lot of things that they ask in OS, like what are deadlocks? How you can resolve a deadlock? Can you create a thread which contains a log? And you are writing something of a code where you're saying, okay, fine, you are creating up a deadlock and you can remove the deadlock, write a code for removal of the deadlock and stuff like this. So these are the things. You might have done this in the course where you learn operating system as a subject in your BTech. You might have learned this all up, right? देखा होगा आप लोगों ने इसको पहले भी. So these are few things that they ask in your OS. Anything else that you want to ask? Anything else? And if you're okay, and if you do not want to ask, you can just give me a yes so that we can end up with the session. How to start on HackerRank? Sign up, and the platform is gonna scroll you around and move you around itself. Just sign up. Start with competitive programming. It's gonna make you revolve around all of these things. There are big challenges that you can sit around and write code for 2 to 3 hours. That is also something that you can do. And this is all. All right, guys. So I just hope you do not have much questions. So that was all. I had a lovely session. So I focus more towards coding or projects, both. Learn coding while doing projects. This is the goal. This is how you should work. Okay. So I just hope this is all for the session. Thank you so much for joining. Thank you so much for interacting. That was all that I could give you in this 2 hours, though typically it's expanded to 2.5 hours. Developer versus competitive programmer. Developer. Definitely developer. Definitely developer. See, competitive programming में सिर्फ आप coder रह जाओगे. You'll never become a developer. And this is the real scenario, typically speaking. You have been a lovely people who have been listening, though, right? So if you've not been so patient, I just hope this session was informative to you and you learned something out of, because that was the main goal of the seminar, right? And it was a lovely journey having taking a session with you guys, and this was really cool. This was really amazing. I just hope this make an impact to you, and this gives you a little information, a little insight of how industry works. Though there is, again, a lot of sources, a lot of resources that you can come across with. And of course, CipherSchools is waiting for you. to be a part of your CipherSchools, and we're gonna meet up back tomorrow, sometime, right? Tomorrow. Anyways, so that was the all. We're gonna meet up sometime. We're gonna have a look on it, and if you definitely need these sessions more, we can talk to the management and we can make that happen as well. Okay, so that was all, guys. That was all, and thank you so much for joining. Lovely having you people on board, and that was it. So if you are good, we can end up the session, shall we? Can we end up the session? Can we end up